4.3 is properties of logarithms, and this is going to be a one-day lesson. All right, so objectives are going to be, we're going to use the product rule, the quotient rule, the power rule. We're going to expand log expressions, we're going to condense the log expressions, and we're going to use the change of base property. So the product rule says let b, m, and n be positive real numbers with b not equal to 1. Log base b of m times n then will equal log base b of m plus log base b of n. So the logarithm of a product is the sum of the logarithms. So it's kind of like with the exponentials. So remember when we did exponentials last semester, we had the rule that said if we're multiplying, if we're adding, you multiply the exponents. So like if we had x squared times x cubed, that would have gave us x to the 2 plus 3, which would have been x to the 5. So it's kind of the same idea. Because they're being multiplied here, we can separate them by using addition. So this log base b is going to go with both of them, or with everything that's being multiplied, and we put plus signs in between them. So here we got log base 6 of 7 times 11. And so we're going to do that because we see it's being multiplied. We can expand them by using addition. So that log base 6 is going to go to the 7. Plus, because it's being multiplied, and then the log base 6 goes with the 11. And then if we could work out either one of those, we would need to. But at this point, we can't. All right, the second example there, log of 100x. Don't forget, anything side by side means multiply. So even though I didn't put a little times thing in between the 100 and the x, we know that the 100 and the x are being multiplied. So we're going to take log of 100 plus log of x. Now in this one, because it's log of 100, I think we can work it out. So we're going to go to the side over here, and we're going to work it like what we did in 4.2. So we got log of 100, because it's in log form, it's equal to y. Remember, log it's a common log, so its base is 10. So even though it's not written, we know it's a little 10 there. So we know our base is 10, our x is 100, and our y is y. So I'm going to change it to its exponential form. B to the y equals x. Remember, we can rewrite 100 as 10 to the second. It goes down to a base of 10. My bases are the same, so we ignore them. And so we know that y is equal to 2, which means that log of 100 is equal to 2. So I'm actually going to put that here. So this is 2 plus log of x. Now, on the log base 6 of 7 and the log base 6 of 11 from the previous one, those wouldn't work out, so I didn't try them. But you should always check. If you have log of a number, check and see, can you simplify it? All right, the quotient rule says that if you have log base b of m divided by n, you can separate them by using a subtraction. So it's kind of like the exponential rule that says when you divide, you subtract your exponents. Well, here when you're dividing, you subtract your logarithms. So the first one here, we have log base 8 of 23 divided by x. So we're going to take log base 8 of the numerator minus, because it's a fraction, it's being divided, log base 8 of the denominator. Log base 8 of 23 I can't work out, so I'm just going to leave it like this. The next one, so we're going to take the natural log of the numerator minus, because it's being divided, natural log of the denominator. Now I can't do anything with the natural log 11, but we know natural log has a base of e, and this first one has an e in it. So I'm going to come over here to the side and see if I can work this one out. So natural log of e to the 5th. Remember, natural log, well, we said equal to y. Natural log is the same thing as log base e. And then we still have our e to the 5th equals y. So my base is e, my x is e to the 5th, and my y is y. So b to the y equals x. Bases are the same, so ignore them. And so we get y is equal to 5, which means the natural log of e to the 5th is equal to 5. So I got 5 minus the natural log of 11. All right, then we have this power rule. And so the power rule just basically states that if we have log base b of m to the p, that's equal to p times log base b of m. So we can take this exponent, this power, and we can move it to where in front of its log, and it'll become multiplied. Or if I have a number in front of the log, I can move it back as an exponent. Either way. Alright, so using the power rule to expand this, notice we have this exponent here, so we're going to move it in front of its log. So it's going to become 9 log base 6 of 3. Now, can we work out this log base 6 of 3? I don't know. Let's find out. So log base 6 of 3, it's in log form, so I'm going to set it equal to y. So my base is 6, my x is 3, my y is y. So b to the y equals x. Be careful, will 6 go down to a base of 3? It will not. So therefore, I can't work that one out. So this is as far as we can go. All right, on the next example here, we notice we have this power, this exponent. So let's move it in front of its log. So we got 2 log, and we still have to keep this in parentheses, the x plus 4, because that's what we're taking the log of. If we drop the parentheses, it means we're taking the log of x, and then we add 4. But this wanted the x plus 4 in parentheses, so keep it there. Can't work anything else out. So there's our answer. All right, so this is just going over those properties. We have our product rule, which means we're going to separate them by adding, or if they're being added, we can put them together with multiplication. The quotient rule, if they're being divided, we can separate them with subtraction, or if they're being subtracted, we can put them together with division. And then the power rule, we can take the exponent and make it the coefficient, or if we have a coefficient, we can make it become the exponent. All right, so now we're going to put it all together, and we're going to use the log properties to expand. Remember, to expand means to make bigger. So when I look at this, I first notice I have 2 things being multiplied. I have that x to the 4th times the cube root of y. So because they're being multiplied, I can separate them using addition. So I got my log b of x to the 4th plus my log b of my cube root of y. Now I'm going to work on this last one just for a minute here because I have that radical, and we can rewrite that. We talked about that in 4.2 day 1. So I'm just going to bring down this first part, log base b of x to the 4th plus log base b, and remember we can rewrite that as the base, which is y, raised to its exponent. It doesn't have 1 written, so it's 1 over the root, which is 3. So that's y to the 1/3. And then we don't have any more multiplication, no division, but we do have this power rule, the powers here. So we can move both of these exponents in front of their log. So we get 4 log base b of x plus 1/3 log base b of y. No more exponents, no multiplication, no division. I'm not taking log of any numbers, so I don't have to worry about working anything out. So there is our answer. All right, again, we're just expanding. So notice I have division, so I can separate them by subtraction. So log base 5 of my numerator minus log base 5 of my denominator. Now also notice, be careful here, this denominator is being multiplied. So that 25 is being multiplied by the y cubed. So I'm going to go through and separate that. So we got log base 5 square root of x minus, now I'm subtracting all of this, so I'm going to put it in parentheses. Log base 5 of 25 plus, because of the multiplication, log base 5 of y cubed. I'm going to go ahead and distribute that minus sign so I don't have to worry about the parentheses. So I got my log base 5 square root of x minus log base 5 of 25 minus log base 5 of y cubed. Now we've got this radical in here. We know we can rewrite that, so I'm going to do that here. So I've got log base 5 of its base, the x, to the exponent, which is a 1, over the root. Remember, there's no root written, it's a 2. Minus log base 5 of 25 minus the log base 5 of y cubed. Alright, so I do notice I have some powers I'm going to need to deal with, and I have log of a number I need to check out. So let's see, this power will go in front of its log, so I've got 1/2 log base 5 of x minus, I'm going to come over here to the side and I'm going to check on that log base 5 of 25. It's in log form, so I'm going to set it equal to y. So my base is 5, my x is 25, and my y is y. So b to the y equals x. 25 will go down to a base of 5. 25 is 5 to the second. So I have 5 to the y equals 5 to the second. Ignore your bases because they're the same. And so we know that y is equal to 2. So we know that log base 5 of 25 is equal to 2. I'm going to put that there, minus, and then I have another power here, so I'm going to move it in front of its log. So I got 3 log base 5 of y. No other power rules. Simplified my logs. There is my answer. Alright, and there is our rules again. Same things, but now we're going to condense them. So the rules are the same, we just go the opposite direction. So we're going to write this as a single logarithm. And so we can see we have log of 25 plus log of 4. They have the same log base. They're being added, so we can combine them by multiplication. So we're going to write down the log with its base, which, remember, this is the common log, so it's base 10, of the first times the second. And then simplify that. So we got log of 25 times 4, which is 100. And then because we do have log of a number, we need to see, can we change this? So I'm going to do this over here, or can we solve it? Excuse me. So we got log of 100. It's in log form. Let's set it equal to y. Remember, the common log has a base of 10. So my base is 10. My x is 100. My y is y. So b to the y equals x. 100 will go down to a base of 10. It's 10 to the second. And so I'm going to bring down my 10 to the y. Bases are the same, so we know y equals 2. So that means that log of 100 is equal to 2. All right, and that works with any of them, okay? So we don't have an example of here where if they were being subtracted, but if this one had been a minus, then we would just put it as log of 25 divided by 4. You just do the first one goes on top, the second one is your denominator on bottom. All right, and then the change of base property. So if I have log base b of m, I can rewrite it as log base a of m over log base a of b. So I'm changing the base. The main reason you usually want to change a base is so you can either work it out. So like when we had that log base 6 of 11 earlier and I said we can't do anything with it, we can change a base where we could work them, or is so that I can put it into the common log or the natural log so I can use my calculator. But notice, this is log base A. A is our new base, okay? And then the m is going to go to the numerator, and the b, the old base, is already subscript. It's already down a little bit, so it's the one that goes in the denominator on bottom. And then here it is with your common logs. So if you have log base b of m, you can rewrite it as log of m over log of b, or the natural log, you can, log base b of m can write natural log of m over the natural log of b. And so use common logs to evaluate. So we got log base 7 of 2,506. So we're going to use our common log. So it's log. Remember, this is written higher, so it's going to go on top. So 2506 over log. And this base is written lower, so it's going to be the one that goes on bottom. So we're just going to put this into our calculator. So log of 2506, close the parenthesis, divided by log of 7, close the parenthesis, enter. And I got 4.022. Alright, now we want to use the natural log to solve this. The same idea, but now instead of log, we use natural log. So we're going to have the natural log of 2506 divided by the natural log of 7. And so you type that in your calculator. Don't forget to close the parentheses. So natural log of 2506, close parenthesis, divided by natural log of 7, close the parenthesis, enter. And we got the same answer, which I expected because we're working the same problem. Same problem, same answer, just two different ways to work it. So it doesn't matter if you change the base to natural logs or common logs, we're going to get the same exact answer. All right, and that is the end of 4.3.